greenhouse gas emissions associated with the consumption of energy in the house, so it's operational energy rather than necessarily associated with its embodied energy, and over the course of a year. So that was the sort of the definition that we used for this particular house. How do we achieve zero emissions? Well, it's a combination of ways that buildings can achieve this. You basically want to bring down actual energy demand in the home, of course, and coupled with that, you then want to tie it in with a renewable energy supply. Usually, it's going to be PV. And it's really this crossover point when if you're matching your supply with your demand, that you're going to get that zero emission status in the definition that we use. And really what we developed the Aussie program to say that a house that achieves that magic status there would be considered an Aussie 10. So 100% covered by its renewable energy supply would meet 100% of its demand. So the house itself now, it's an interesting one. People have asked, why was it built this way? Why was it done in the way we went about it? We purposely chose a volume builder, such as in the case of Henley. We purposely chose that we wanted to demonstrate that mainstream housing could achieve these zero emissions. You could build a high efficiency home using fairly stock standard building practices and using a volume builder to achieve that. So we didn't want to have a sort of a one-off home that was sort of saying, it's nice, but I wouldn't really want to live in that. The whole idea was to build a home that mum and dad buyers could walk in and say, oh yeah, this has got everything in it that I like. This has got all the facilities, all the type of bits and pieces that go into a house that I want, and that it's not going to cost that much more than building a stock standard house. So as you can see, it's relatively large. That's pretty much smack on the average for homes that are built, detached homes that are built today, so 240 square metres, that includes the garage. It rated at 8.2 stars, so people are familiar with the star rating system that's used for new houses. We have a minimum requirement now of a 6-star rating. The house achieved an 8.2 star rating. To get to 10 stars, for those that just to let you know, the 10 star, if you get to a 10 star rating in a home, that effectively means that you don't need any artificial heating and cooling in the home. It gets progressively more and more difficult to get to that 10 star level, so around about that 8 star level we think is a fairly good sweet point as far as achieving good thermal comfort without blowing the construction budget. Had a fairly large PV array on it. It's got a 6 kilowatt PV system sitting on its roof, and of course it had all the low energy lights, appliances. We put in a full control and monitoring system because we wanted to see how this house is actually going to perform, and we also did other stuff that sits outside of the energy space, but with water efficient systems, so it had water capture for grey water which was used for the toilets and for the laundry and in the garden and things like that. That's the, as I say, it was, we had it been fully monitored. So all the power that was generated on site from the PVs, we monitored that. We looked at how much was drawn, how much power was drawn from the grid. We used the grid as the battery, so we didn't have standalone batteries in the home, again, because that's at the time the house, but that was a very expensive, still is a very expensive option to do that. So we did utilise the grid as our battery. The house did have air conditioning and heating. People again have sort of said, oh, that's a bit of a, if you were trying to build a passive designed home, why did you put an air conditioning unit in there? It was probably more a market-driven option there, but again, the whole idea, and again, working with people like him, said if you're going to make these homes marketable to the general public, people do want a heating and cooling system in their home. So we did have one in there. electric. The entire house was electric, so we had an electric hot water booster. Oven and cooktops were monitored, refrigerator, washing machine, dishwasher. So we had about 20 different circuits in the home that were all being individually monitored by our system. And you can see there, that photo down there is the bank of sub-meters. It's interesting to see how our technology has moved on. At the time that we wired this house up, there really was no off-the-shelf system for monitoring circuit by circuit energy consumption. So we pretty much had to build one ourselves, and it's a whole lot of sub-meters. So it took up an entire wall in the garage of the home. Yeah.
Have you got figures on all those meterings for the year?
Yeah, we'll get onto it. Yep, sure do. We also came up with that top screen. The house had an in-home display unit as well, and we developed that. This was developed in conjunction with La Trobe University, and the idea was to try and give the occupants. We put a family into this home. And the idea was to try and give those occupants a sense of how their home is performing and give them an indication of are they doing well, are they doing bad. So I don't know how well you can see there in the pictures, but you can see the different spaces have got different tones. We've got some that's green, it's a bit of yellow, we've got a red up there. And that was basically that green means that zone is your energy consumption, and that zone you're doing fine. If it's red, something funny is going on there, and you could touch on that, and it would give you an indication of what's consuming the energy in that particular zone of the house. And the idea was that then they could potentially make a conscious decision to switch whatever it was off. So these in-home displays that try and provide the user with a simple interface, simple feedback mechanisms, was what we were testing out as well. So, so what we did, we basically collected we collected about 2 years worth of data on this house. We put a family, it was a fairly large family as it turned out. There was 3 adults and 2 younger kids and a teenager in there as well. So there was quite a large family that was in the home, which is something that we weren't actually expecting, and it did have consequences for how the house actually performed. But you can see there that the energy consumption in the house was pretty much dominated by the HVAC system and also the hot water system. Those 2 things alone are much more than 50% of the total energy consumption in the house. So a lot of the other things were actually only quite small energy consumers, but it was really those 2 things that were significant draws of the energy.
Michael, what takes 12% of the energy in the living room?
Entertainment systems.
What,
Yeah.
plays on the TV or something?
Yeah, and I'll get onto that because it was interesting looking at, and it comes back a lot to the human behaviour, about how people. We purposely put this family in with giving them virtually no information at all on how to operate the house. The whole idea was if you just throw a stock standard family into a home like this, how's it going to go? So that's what we did, but it was interesting because the house, in an attempt to provide energy efficient appliances, we actually provided things like an energy efficient fridge, and we actually included 2, at the time, energy efficient televisions in the home. But of course, silly us, we didn't realise having a family moving in, they had all their stuff as well. So they weren't going to leave that unplugged sitting in the garage. They plugged all their other stuff in. So we had, was it 4 televisions in the end, Adam? We had four, and we had 2 big plasmas. They had the fridge going in the garage, which is why that garage was actually red. That was the bar fridge. That was the beer fridge running. So yeah, it was interesting that although we had tried to say, okay, we're going to provide them with all this stuff, we didn't actually probably should have built into the whole program to say, and you're not allowed to plug in all your stuff that you bring with you. but they did. So again, it's an interesting exercise in the human behaviour side of things. So actual versus expected. So this is where it does all get interesting and from a researcher's point of view. So this is what we expect. So we did modelling on it. There's some fairly sophisticated modelling that we did, and this is pretty much what we expected the house to do. So it's going to be a pretty flat line performance over the year, popping up a little bit in June and July, because again the house is all electric, so that was the heating. There was going to be a bit of we are a heating dominated climate, so there's going to be a little bit of a heating requirement there for the home in that June-July period.
Michael?
Yeah.
The energy kilowatt hours, is that what, per month, week?
That would be per month.
Right.
Yeah, yeah. It is a little bit, I must admit, look, it's a little bit, I had to do a bit of a refresher on this. It's been a while since I've actually done a presentation on this particular project. So you can see whether, David, you can trip me up with, you said you were going to bring tricky questions. David's another CSIRO pod. So he said he was going to bring tricky questions for me.
I see what you think up.
Okay, so that was, so the dark line there, that's what the house expected. That line there, that's what we expected the PV. So you can see there, we thought we were going to be well and truly safe as houses as far as meeting the zero emission target. The PVs were going to, romp it in as far as providing the energy for the house. That's what the PVs actually did. So they tracked pretty close. There's some reasons why they didn't do quite as well, and I've got some information. That was mainly to do with we had the summer that we monitored over was a particularly cloudy one. So the PV.
Can I just ask the modelling? Did you do that on previous real modelling or software modelling?
Software modelling. Yeah. So it was a souped-up version that most people that if you're I don't know if it's any assessors here, but a souped-up version of the Accurate software. So the software that's used for rating.
I'm talking about the PV now, sorry.
Oh, the PV. The modelling on that. I think that was just from memory. I think we just used something like PV Watt to do it. Yep. So but PV modelling is pretty simple to do. So. Oh dear. Yeah. So this is what this is what actually happened. We were all a little bit surprised, to say the least. You can see that enormous winter energy consumption that went on. And even during the summer, everything across the board was above what we expected by a long way.
Did you do a graph and work out what it would be if it was an older style house without all the 10 or 8.2 stars? Without consumption?
Well, a lot of it was down to, look, most of it was, nearly all of it was down to human behaviour. Look, it's actually interesting because the house itself has now been sold, and the new owners are much more in tune with how the house is operating. We're about to put monitoring equipment back into the house again and monitor it again, and see when you've got an educated household in there, the difference that it makes. Look, and I don't want to be critical of the family that was in there. It's a really interesting exercise in that educational requirement in these homes. These homes can't operate. They won't just magically provide fantastic savings without you interacting with them. You really do need, just like with a fuel-efficient car. If you drive a fuel-efficient car like it's a Ferrari, you're not going to get the fuel efficiency that the manufacturers claim. It's the same with homes. So this is basically broken down by the circuits. This is where the power of the energy went, and as you can see there, it's dominated by that HVAC over winter, and and also the hot water system. So get that one down. You can see there the PV, the red line is the PV, and you can see naturally it's going to drop off over June. So in summer it was keeping pace with the home. but it couldn't cope with the winter.
I don't suppose you were measuring the water, because I mean, hot water like that, to be able to go what you projected as opposed to what they use. I mean, it sounds like they might have subconsciously trying to break this somehow too.
And I'll get on to the few interesting things that they did. Oh look, I can talk about it now. So one of the things they did with the HVAC, they were very keen on natural ventilation. So that all sounds well and good, but they like natural ventilation in winter. So they ran the heating system with the doors and the windows open.
Yes.
We all do laugh, I know, but that's what they did. They said, "Oh, that's how we like the home, and it's such an efficient heating system. You know, it's great. It's heating the home's fine."
Yeah, in really tight houses, some houses, I'll have a late HRV system in there to keep that fresh air, that regular air interchange.
Yeah,
you did have that, or you didn't?
No, we didn't. The house was pretty tight. What was it? Was it 6?
4.8.
4.8. So we had it pressure tested, so it was 4.8 at 50 pascals pressure. So it wasn't tight enough that it required an active ventilation system like that. But it was a pretty tight house. I mean, that's a lot of the average. The average in Victoria for new homes is around about 20 air changes per hour of pressure. So we had it at 4.8. So it was a pretty tight house. If they closed it up, it would have performed.
So, but I wonder if you would have got that same behavioural pattern if you had an HRV in there.
I think we probably would have. To be absolutely honest with you.
Okay.
Yeah, I think we probably would have.
Michael, did you baseline the house without people? 'Cause I'm curious to know
Well,
what its performance was as a passive house.
Yeah, well,
before you start throwing energy at it, and before you start throwing people at it, which skews it again.
Yeah. Well, the modelling didn't necessarily model it as a passive house. So within that, there was heating and cooling requirements as the model thought was going to be required. If you're saying, did we monitor it in an unoccupied free running state? Is that the sort of thing you're?
Well, yes, and in fact, did you design it with the right orientation?
Oh yes. So it was all passively designed. So it was all the house is orientated to the north. That's how it's achieved the 8.3 star rating, because it really was designed around passive house principles. But having said that, and to be honest, if it had been my house, I probably wouldn't have bothered. I might have had a split or something like that in the main living space. I probably wouldn't have bothered with it. It's a big ducted heating and cooling system that was in the house. I probably wouldn't have bothered with that, and being, an understanding of how these homes operate would have been able to operate the homes in a much more passive way. So, but we didn't actually model it after the house was built. The monitoring really began pretty much when the household moved in. We did a little bit of testing of the system, didn't we, Adam? But
it was on and off with occupancy.
Yeah,
being open on weekends. And
yeah, because it was open. That's right. Because we had the house open as a display home, and that's always creates weird and wonderful data as well.
The hot water service, what sort of heating did you buy? Was it resistive heating or was it air compressor?
It was a flat panel, a twin panel flat panel solar system with storage.
Yeah, the electric booster.
Yeah, electric booster.
Resistance booster or?
Yes.
What was it? I think it was. Yeah. Look, and again, I think had we had our time, again we had some issues with the hot water system. Had our time again, I think we probably might have put in a heat pump. So I don't know, what do you reckon, Adam? I think we probably would have done a heat pump system rather than what was put in there. But all these things were interesting learning experiences about what was going to work and what didn't, as well as expected. So certainly that was, we say poor ceiling. It wasn't really the poor ceiling of the house; it was poor ceiling by the occupants. An increase in hot water over winter. Well, again, we're going to get that reduced solar input during the winter months, so you could expect a bit of an increase there. But I think, like I said, I think we did actually have some issues with the solar hot water system that was installed. This one's an interesting one. You can see that spike there, and we scratched our heads thinking, what in the world is going on with this sudden spike? that went on. It was accidental usage. What happened is the house had, believe it or not, had an electric barbecue.
Yeah, Christmas in July.
They left it on. So it was happily heating up. It was creating a bit of an urban heat island effect. Was going on. How long did they leave it on? Actually, I can't remember now. It was a while.
A couple of days, I think.
Yeah, but it caused that spike that shows up there was from that accidental usage that went on. So again, we had some really interesting user behaviour issues. Look, just to give you an idea of the daily use profile, so what it looked like on a day to day, just over the different seasons. That was what a typical summer day looked like. Its energy consumption. You can see as it gets cooler, you get this typical double hump. And certainly in the winter data there, you get this double hump. So you get a energy use in the morning, so people got up, switch on the heating system, then they all take off to work and school, and so it drops late to school. Well, they did actually have the two of the adults that were there actually were stay at home as well. So yes, that was added to the energy load on that house, and then you've got that afternoon evening spike as well. So this is pretty typical of most houses that you look at will have this type of energy use profile. The daily generation profile, well, again, it's we got all pretty clean there. It's what you expect, and of course, as we move into the cooler months, the PV generation narrowed and lowered, but again, pretty typical of what you'd expect from a PV system. So we're pretty happy with the PVs. They did fine. They did fine. We didn't have any issues there. And sorry, that's all a bit messy, but you can see there that's overlaying the use versus the generation. And so so again, during the day, the PV system was in the afternoon, and the PVs at the back, it was meeting demand fine, but it's these periods here and here where the PV system couldn't meet that demand. It's quite a chart. That's just the sum of performance, just to give you a bit of an idea of what it looked like on a typical January 2012. Some of performance of what we saw on the different days, and you can see it going up and down on the various days. And I think, from memory, yeah. So because the thing with this is when you overlay that with the maximum temperatures that were being experienced, we see that on those warmer days that we're looking probably the higher energy consumption. I think on this year they were actually away on holidays. Thank goodness.
Was the hot water system actually undersized then for the number of occupants?
Look,
There seems a lot of boosting going on.
Yeah, but potentially it may have been. I think we probably had some other issues with. I don't know, Adam, do you want to say anything about the hot? We thought it probably wasn't.
Well, it was probably size for a four-person household.
Yeah, everything was modelled around a four-person, mum, dad, and two kids. So everything was modelled around that type of house profile. So yeah, there was quite a lot of boosting that went on, and again, I'm not sure whether the hot water system was actually performing at its optimum level. Whether it was.
Was it a flat plate collector or was it?
Yeah, flat plate. Yeah, it wasn't a
was it 315 litre tank?
Oh gee, I can't remember now.
It was around 300.
Yeah.
So do you know anything about their usage habits? Are they the kind of people that had the showers in the evening, so that they had to boost overnight, or?
I think they tended to, and they had fairly long showers. teenage daughter, or teenage, it was a niece that was in there. She had
Wasn't there a story about turning hot water on in the morning and waiting for it?
Oh yes, yeah, thanks for reminding me, Adam. Yeah, there was. So one of the things that they also did is they wanted hot water for their for the shower in the morning, and there was that lag. So they would turn the shower on in the morning. Now they're going in, switch thing, and then wander off and make a cup of coffee. So wait for the hot water to come through the system. So you know, it was chugging away happily, popping out all this, not any wasting water, but you know.
Who paid the bills for this after you? Were there?
Well, look, that's another interesting story. That's another
Different
interesting story. I will jump around a little bit here. So with the bills, it's an interesting. The household, they never received an energy bill. So all the bills actually went to Henley. But having said that, the house itself was, when the PV system was installed, it copped we were lucky enough to get the 66 cents kilowatt hour feed-in tariff. So even though the house didn't actually, the amount of energy that the PVs generated didn't actually meet the consumption of the house, because we were getting 66 kilowatts for that time. You know, there was those times when the PVs were exported to the grid. That more than covered financially, more than covered the cost of the house. So the house was, we were miles in. I think at the time the house was sold, it was $3,000 credit, something.
Yeah, well,
It was
always in credit.
It was always in credit. Always in credit. So, so it's an interesting one on the human behaviour side of things. Because had they actually been receiving the bills and seeing that they were in massive credit all the time, would they have used more? Yeah.
There was a statistic with solar that they actually were consuming more when they put in because they thought they're generating more. So the psychological side.
Yeah,
of things.
so,
Or would they have used less because they could then make lots of money out of it?
well, because they didn't get the money, so it was
What if they were?
Yeah, if they were, perhaps if they were, that would probably be different. But because it's always just runs in credit, so you can't, you weren't getting the money. It was just there was a credit there, and of course they were always in credit. So it's an interesting one with that on whether had they actually got the bills, what would have happened? Would they have used even more, or would they have pulled back? I don't know. I think probably if they were getting the money, yeah, they probably would have used less. So that's just just matching up with the maximum outside temperatures and the and how the theories are going. Winter performance. This is again just a day or a profile in July and the various energy consumption. There you can see there. That's the PV. So not even getting close to matching use there. And we can see that it actually spiked. Winter was our big problem area, and somehow that's just a typical a daily performance. Again, it's showing that double spike hump that you get. Again, it's fairly typical daily performance. This is for December, just averaged over the day.
Michael?
Yeah.
That appears to be showing a peak of less than 0.9 kilowatt hours from your 6 kilowatt system. So what's your time scale again for your...
This would have been in 30-minute.
Right.
Yeah,
Even so, it seems well south of the rating of the system.
I think it'll
Might
be
be
30
15 minutes.
I think it's probably
I can't remember now.
It looks like it's certainly not half hour.
Oh, it's not half an hour, is it? No, we're looking at there.
But it's averaged over the whole month.
It might have.
that scale from somewhere.
It might be 15 minutes. It might even be 10 minutes. I can't actually remember now.
Even at 15 minutes, that's pretty low.
Yeah, it's pretty low. Look, the performance of the PVs is what we were expecting. But what I was going to talk about here, the interesting thing on this one is this thing here. This is standby power. that's going on in the house. You know, there's been lots of talk about standby and what does it actually contribute. Well, in this house,
And the fridge.
yeah, and actually for that so in this graph here we took the fridge out of the equation. So, but you're right, that overnight would have included.
So Michael, just a question on the extra fridge in the garage. What circuit did that appear on?
On the garage circuit.
Okay.
Yeah.
The garage didn't appear in most of these graphs, or like I said?
Oh no, it should have been there.
Okay.
Yeah, it should have been there. Yep. Just so I'm hoping that this is sort of just a. Oh, there we go. That's what I was going to say. So the standby actually represented 15% of the total energy use for this house. So, and there are lots of numbers out there. People say it's between 3 and 10. Well, we had 15% that was that we determined was due to standby power. So a lot of that, as you can see, was coming not a great deal from the HVAC. It's actually interesting how much HVAC systems can actually draw. We've done other projects where we're getting some HVAC systems that have a standby of 160 watts in standby. So that's
Michael, would that be included in the COP? Because I bet it is then.
No, it's. I don't think it is. I don't think it is. And look, it's an interesting one again with how the system was sized for the house, because the HVAC industry doesn't really get energy efficient homes. You know, they came along and basically say, oh, this is, you know, you've got a house of this size. They plug in their numbers onto their little spreadsheet and say, oh, you need a system that's this big. And if you go to them and say, well, hang on, this house is an 8-star home or a 9-star home. It's not going to need that much. Or they say, oh, we can't do that. Our computer says it has to be this big. So it was interesting that the HVAC industry is slow to understand how to resize systems depending on the thermal efficiency of the house. And again, what you can see with these spikes in the bedrooms and in the living and in the master, that is all the entertainment systems. That's televisions and the Foxtel boxes and the PlayStation and everything else.
Did you count them up? How many there were?
Oh, there was. I think we had 4 or 5 televisions. 2 of them were big old fashioned plasmas. There were 2 or 3 Foxtel boxes. 3 Foxtel boxes. There was a home entertainment system. The kids had a PlayStation unit. One of the adults there, she was an elderly lady. She had a Foxtel. She had a big old TV and a Foxtel unit in her bedroom, and she used that a lot.
I've actually been in a house that's had 16 PowerPoints plugged in. 16.
I was going to say, there's a bit of laughter, but this is actually a normal.
It is, and look, I know.
It's scary.
And I know households that have got 9 or 10 televisions. You know, you've got 2 televisions outside, and you've got
3 fridges.
Yeah.
I'm intrigued that the standby in some of those areas is varying so much over the year. I mean, standby, I would have expected to be more consistent.
Yeah, look, some of it, it was our best guess. It's hard to determine exactly what is standby. So we tend to look at the overnight consumption and thinking, well, that's probably it when we see a fairly steady. But it might not be. It can be a hard one to pin down.
If you've got teenagers in the house, that's not standby.
Yeah.
This is 3 o'clock in the morning, that's somebody on the computer.
This is sort of a bit before the days of, I should say it's not that long ago, but I can't remember how many computers they had, but I don't think it was sort of prior to the iPad smartphone revolution. But look, one of the other things that's really interesting here, again, this is us trying to get a bit of a feel for the different circuits and how much was actually, of their total consumption, how much was standby and how much was actual the thing was doing something. And it's always an interesting one, because with entertainment appliances and things like DVD players and things like that, they spend around about 90% of their time, or 90% of their energy consumption is standby energy consumption. So they only spend 10% of their total energy consumption is actually them doing something. Yeah.
How did you actually measure your standby?
Look, it was like I said, it was the best guess. So we didn't
data wasn't actually specifically.
No. So we didn't actually specifically know that this device is actually off. So we tried to determine it from, I think from memory, what we did is we looked at the overnight. We looked at at each circuit's lowest consumption. So it's in a 15-minute period, what its lowest consumption was. That tended to be overnight, and said, okay, and we only targeted those circuits that had devices that would have standby power on them, and said, okay, that's the standby power that we're seeing on that particular circuit. Because we had so many circuits in the house, a lot of the things were, the entertainment, so all the entertainment stuff really was on one circuit, and so we were able to get a relatively good idea, but it still was, nonetheless, it still was our best guess. But it's interesting to see, the amount of time some of these areas that the vast majority of the time there's just standby is that's what the draw is, and the HVAC is not. And of course, other things that were able to be switched off completely, you don't get any standby on them at all.
So no smart switches.
No. Oh, we had the house had a, what do I call it, a good night switch, or a, so it basically, there was a kill switch that you could, if they left for the day or at night, they could do that, and it would kill power to all non-essential circuits. So it would keep the fridge going, and I think it had some other device. So we had one to the washroom, and had one for the, so basically we had a system that was able to kill power to...
Did they use it?
No.
Did you tell them?
They did know about it. They did know about it, but they didn't use it. Nor did they actually use so the in-home display unit that I talked about earlier, they didn't use that either. So we had some issues again with, there's a bit again, look, it's the whole thing with, this was fairly, at the time that it was put in-home display systems were almost unheard of. So we had to create one from scratch, and it was a little bit glitchy, I have to say, and they got a little bit jack of it, and they turned the thing off. Actually, I think they put their family photos on it, and that family photos right around it. So there were some technical issues there, but they didn't really use the in-home display system either. So
the grey water system what was going on there?
I don't know. I think we had a faulty pump, didn't we, or something? Yeah. Yeah, that's right. Yeah. So it probably shouldn't be a standby, but it was a faulty pump. That
it was a flow. There wasn't a one-way flow.
That's right.
Control.
Yeah. Some of these things we discovered as we were looking at the data, and we're thinking,
It's not right.
what's going on there? And we'd go out, and Adam would go out and fiddle around with it and say, why is it doing that? And we try and fix them as we could. It's one of the nice things about having live data is at least you can monitor these things and thinking, that doesn't look right, and try and do something about it. So this is just again just on PV performance. Just I mentioned this a little bit before. Just how we saw those graphs before, which is lovely. Lovely parabolic curves, but of course PV performance does go up and down depending on climatic conditions. So this is just like for January each day, and this is just mapped with the amount of sunshine hours that were recorded on those days. And you can see you get a pretty good correlation there between when the sun's out, PVs are doing what they're meant to do, and when it's cloudy. They don't perform as well. So, and this is just another way of looking at it too. I don't know whether people know about this Octus rating. That's basically amount of cloudiness in the sky. So 8 there means total cloud cover, and 0 means completely cloud-free sky. So again, this is for a winter period, so we can see, you know, lots of, and it's measured. It's just a visual thing that the Bureau does, and they do it at 9 AM and 3 PM. So these are the recordings over this period in July. So we can see lots of cloudy days there, and again, when you map the PV generation over the top, you hardly be surprised, but it's good to see that you do get this type of correlation. So on the days where we had fairly low cloud, that's when the PV is performing at its best. So it's just always interesting to know that PV performance is going to be affected by these various climatic conditions. Did we achieve zero emission? Well, you can probably guess the answer to this. No, we didn't. However, having said that, we didn't do too bad, considering the family that we were up against. So the house still did produce around about 71% of the home's energy requirements, and those energy requirements were high. So we didn't do too bad. If we got rid of the HVAC system, we would have been at about 108% of the energy requirement, and if we got rid of the hot water system, you'd be at about 172. So those two systems, the HVAC and the hot water system, were our that Achilles heel for us. So most of this I really have already talked about during the discussion, but really, if we had higher household numbers, so we had more people in the home than we thought. A much higher number of appliances than what we modelled, things like multiple televisions and stuff like that. Reduced use of the airlock. I didn't discuss this. The house was designed so as you came into the house, it had an airlock. So it had another door that led into the main open plan home. So there's a main door, another door that led into the main living space. Now the idea with airlocks is you keep the airlock closed, and as you're going in and out of the house, you don't lose that conditioned air. They chopped it open, so we didn't get that airlock effect. Lots of opening and closing of windows, or lots of opening of windows. We had some quite sophisticated shading systems. We had vertical shading devices that that you could wind down to shade the windows. We had an extendable awning system that was over the alfresco area. The feedback we got from them is they really didn't use those systems all that much.
They weren't automatic.
No, they weren't automatic. We purposely wanted to avoid having automatic. I mean, automatic systems are there's just more things to go wrong, and they may use power, of course. So we purposely avoided having automated systems, but yeah, that would have been a good idea. We had that accidental consumption that I talked about. They really didn't look at the monitoring system that was in the home. The lack of energy bill information, don't know what, as I said, don't know what the impact might have been of that, if they actually seen their bills. And we did have a cloudy summer, which means that the PVs weren't quite at their peak performance, but they were pretty close. This is not from the house. I was just going to quickly talk about this as well. So this is a completely different study that we've done. Because we did a large study on the 5-star rating of homes. And we're basically looking at have homes actually achieved have the higher star rated homes actually achieved the energy savings that we expected from lower star rated homes. And one of the things we found out from that particular study was that in winter, yep, we're all okay. But in summer, we weren't really, we were seeing, often in the higher star rated homes, believe it or not, we were seeing higher energy consumption in summer than in lower star rated homes. So we had 4-star rated homes, we're using less energy in summer than a 5 or 6-star rated home. And we were there, again, scratching our heads thinking what is going on. And most of it was being driven by air conditioning consumption. Now, one of the things that we thought is going on there, the modelling software, the NatHERS software that's used to rate homes, particularly in summer, assumes a certain amount of natural ventilation is going on. So it's built into the program, and the program assumes that it's going to happen. But of course, natural ventilation requires human interaction, and you need somebody in the house to. Winter's not so bad because basically the house is sealed up. That's pretty much what the model says how the house is going to operate.
So, sorry, Mike, is this night purging or is this?
So it's basically night purging. So the software assumes that a certain amount of night purging, and when it is cool, is going to occur. So there is some allowance for natural ventilation in the software. Yeah.
I could also tell you, a former energy rater, that you paid a lot more attention as an energy rater to the winter performance and summer performance, because that's where you got the maximum bang for your buck.
Yeah.
So
Yeah.
if you had a choice of doing stuff, you would go in and do the stuff on the winter performance because it was so much easier to achieve with the software.
Yeah, and absolutely, and so typically with our, especially here in Victoria, we do our thermals, we do lots of insulation and stuff like that. So we've got lots of ways to hold that heat in, but of course in summer that means that heat will be held into the house. And for night purging is meant to try and deal with that, but our guess was that this is not really going on, and it's a human behaviour thing. So we did a little study of 4 homes, and this is just one of them, and it's just interesting data to have a look at.
Michael?
Yeah?
Was there any air quality monitoring system?
No. I'd be really keen to get back in and do the air monitoring, but no, there wasn't. So what you're seeing here, it takes a little bit of time to get your head around what this graph is actually representing. Where we basically put sensors on 4 doors or windows. We asked the household, now what doors or windows do you open to get your natural ventilation? We put sensors on each of those, and basically the height of the sticks here represents how many of those openings are in a half-hour period. How many of them are actually open? So when they're down low, this means that just one's open. That's 2. That's 3. So we've got this over there. We've pretty much got them all open. And the width is the amount of time that they spend open. So what you can see here really is that the windows and the doors are really not spending a great deal of time open. In fact, what we found from these homes here is that about 96% of the time, windows were closed in the homes. And this was just over a summer period. And when we put over the top of that the inside and the outside temperature, so the outside temperature is the lighter coloured line there, and the inside temperature is the darker line there. And you can see, naturally, as you expect, outside temperature is going up and down as it goes from daytime to nighttime, so it cools off down the night. You can see here that's 20 degrees, so you can see here we're getting some nice cool temperatures here. And really, these are the points where these are the night purging opportunity that exists. So this is where we've got, our light blue line is below our dark blue line, so this is where you've got your opportunity to get in some cool air from outside. But as you can see, we don't have any windows open, and it was all the 4 homes that we looked at. This was the same sort of pattern that we saw. We saw a lot of opportunities for overnight cooling not really being taken advantage of. And look, there could be a whole lot of reasons for this. A lot around security and stuff like that. That people don't like leaving their windows open at night time. But the interesting thing is that, of course, that the software and for homes to perform well passively, they do. In summer, they do require some of this outside cooling. It's interesting too to note here that when they did it, this period here where the windows were open for the most time, the outside temperature is actually warmer than the inside temperature. So they were actually bringing in hot air from outside here. And of course, when we look at their air conditioning consumption, that's the air conditioning circuit. You can see that's pretty much how they maintain internal temperature comfort, was by shoving on the air conditioner at these points here to try and bring the house back into a comfortable state. So it's just interesting to look at these types of human behaviour aspects, and really it comes back to getting that education out there to people, say how people should operate their homes. Now, do people know about this character? So he's a Garden in Australia presenter, and he's built himself a 10-star house over in Perth, which is all wired up and monitored, and he's got a very, very good website. And how am I doing on time, by the way? Am I fine?
Yeah.
Because hopefully he came out here and he was keen to see the zero emission home, and so he came out just a few months ago and did a video of the house. So myself and Adam, we both got roped into being movie stars. So I thought it was worthwhile just playing. Hopefully the video will work. Playing the video because it gives you a good view of what the house actually looks like. And it's got me babbling on more, and Adam, he babbles on too. Don't we, Adam?
Indeed.
Yeah, indeed. So hopefully, let's just see if it'll work. Looks like it's going to. Alrighty, let's give it a go.
My name is Josh Bird, and for the last couple of years, I've been working on my own high-performance sustainable housing project near Fremantle in WA.
His website's really good. It's got some really high professional videos
And
that
I
he's
was
done
driven
on
to do
it.
it
So it's
through a strong belief that there is a better way that we can be designing and building our homes. Now that the houses have been completed and are gathering data that shows that they work, I've set myself a new challenge. I'm heading off on a groundbreaking national research tour, visiting the very best affordable, high-performance housing projects that I can find, and bringing them together in one place for the very first time. I want to see if they truly are a realistic and affordable option for the mainstream housing market in Australia. And if they are, I want to know what's holding them back. This is Josh's house, Star Performance. I'm on my way to check out a project called the Zero Emissions House, which is about 30 k's to the north of Melbourne in an outer suburb. And it's a project that I've wanted to see for some time, and I'm really looking forward to it. I reckon Melbourne is a great place to start my tour because it's under real pressure from rapidly increasing population and sprawling urban development. With this in mind, to me, energy efficient housing design should be a priority. The home I'm visiting is the result of a collaborative project between Henley Property Group, the CSIRO and Delphin Lendlease, and was completed in 2010. It ticks the boxes to be part of my Star Performers research tour because the project's aim was to design and build an affordable and accessible high-performance home for the mainstream market, and, importantly, monitor it and collect data to prove that it works.
Well, right with the US.
Liking the look of it. Good to see a decent front yard landscape, which always rocks my boat. Michael.
Hi Josh, how are you?
Nice to meet you.
Come
How
in,
are you?
come in.
Thank you. It's great to finally visit.
Oh, come in, I want to show you around.
What a beautiful home. Michael and his wife Carol are the new owners of the house. They've been living here for about a year and are settling in nicely. So how are you finding it living here?
Oh, we just love it. It's fantastic. It's warm in the winter, it's cool in the summer, it's quiet, it's easy to live in. It's just a really nice place to be.
Yeah, once you've been in a solar passive home, there's no going back, is there?
It's really fantastic.
Solar passive design is the golden rule when looking to achieve a high-performance, energy-efficient home in southern Australian climates. And this is reflected in this 4-bedroom, 2-bathroom family home. What this means is the orientation of the home makes use of our #1 energy resource, the sun. This house uses the sun by having all living areas facing north, with windows positioned to allow light and warmth in, which is then retained by the insulated slab, walls, ceiling and double glazing. There's also clever block-out screens and a motorised awning for summer shading, complemented by a high energy efficient and zoned ducted reverse cycle air conditioning system. The 8-star rated home is also equipped with energy efficient lighting and appliances and a high efficiency solar hot water system. In fact, everything in the home runs on electricity, which is completely offset by its 6 kilowatt grid connected solar power system. The zero emission house, which by definition means the home generates more energy than it uses over the course of the year, also has rainwater tanks that feed the toilets and garden taps, and a grey water diversion system for garden irrigation. I think this is a standout example, and I'm interested to hear if it's cheap to run.
Well, this house here, there's no energy bills whatsoever. So that $2,000 to $3,000 that a typical household would have to spend on their electricity and gas bills, this house has zero. In fact, they're actually in credits.
So do you think if the average home buyer knew the money they could save by having a high performance home, that they'd be asking for that?
Yeah, look, I think that is true. And of course, electricity prices and energy prices are only going in one direction. So those savings are going to get bigger and bigger each year. Now I think there's a lack of understanding in the community about what is actually
That's the airlock area.
Right from the start, that was our primary aim, was to demonstrate that this is quite feasible, quite doable, affordable, and you can achieve it.
I think when people come to this house, they're expecting straw bales, mud bricks, and something that looks a little bit sort of kooky. They see this house and they go, wow, it's a really nice house, it's slick, I'd love to live in this house. So I think they're quite surprised when they see what a zero energy house really looks like. So I think there's a little bit of market education required. And the other factor is, the builders need a little bit of probably help getting up to speed with what's required. It's not rocket science, but there's a couple of little details that need to be ticked off as you go through design and construction. And one of the classics is air tightness. And, to make a zero energy home in this climate, you can't be losing all that conditioned air to the environment through leaky windows and the like, and that's something that often gets overlooked.
Air tightness is a concept that we don't hear much about in the warmer climate regions of Australia, but it makes complete sense, especially in a place like Melbourne, where you have to contend with bitterly cold winters and you don't want to lose warmth. But one of the things I'm most interested in is occupant behaviour. How does the way that people live in a home affect the performance?
Homes do not operate in isolation. They do need interaction with the occupants. People need to know how to ventilate the home, particularly in summer, natural ventilation, getting that overnight cooling of the home. And if you don't do that, the home is going to struggle to achieve what it's truly capable of. So it is really important for people to get that understanding, that education about how to operate their home effectively. And it's going to be their biggest purchase that they're ever going to make. Working out how to operate it correctly and efficiently is really a key thing, and it's probably, like I say, really that missing part of the jigsaw about how do we educate people in the operation of their homes.
The zero emission house has gathered some great experience and data in terms of occupant behaviour. The home went through a test phase when first completed, and a large family moved in and pretty much ignored the tips to attain the best operational performance. But the results were compelling.
Had a family living in the house that pushed it hard for a period of around about 2 years, and as hard as the house was driven, it always returned a credit on our electricity bill.
So you say that the people who were living here during that test phase, they drove it hard. That's an interesting term. How hard did they drive it? What do you mean by that?
Well, going back to the car analogy, like you can give someone an fuel efficient car or a very thirsty car. You can drive a thirsty car easily and extend its fuel economy, but it's still going to be higher than that fuel efficient car, even if it was driven hard. So we've got a very fuel efficient house. They drove it hard, but it was still fuel efficient.
At the wheel now, driving the home, is of course Michael and his wife Carol. And they're keen to see what it can really achieve. But they're also finding that purely living in the home is already having an interesting impact on their family and friends.
Something that's been interesting that's happened, we've had friends come out and visited, and they've loved the house. We spent a lot of time here, they've enjoyed being in it. The most interesting thing is that we've been to lunches and dinners later on with those same friends, and they say, "Oh, tell everybody about your house." And we go, "Oh, good." No, they're not interested. "Oh, yes, you should tell them about it." And it's quite interesting. Everybody is engaged in the conversation. Yeah, there is a genuine interest, but I think that people feel that they can't access it in some way. It's just a great way to live. It's where people ought to be. It's all, what we should all be doing, I think.
I think if we could plant some seeds of, I think best in class, if you like, sort of examples of what needs to be done, then the market gets to see that and people get to move into those little communities and actually the feedback will be, "Hey, this is fantastic." So it's like planting the seeds in different areas, I guess, and building up a little bit of a groundswell of momentum. And I think then everyone will move together.
I think what the biggest thing to do would be education. I think education of the buying public. I think if they became aware of what is actually possible, what is actually doable, they would start demanding from the building industry, and I think then the industry would just naturally follow. The industry is out there, it will deliver what the client wants.
I reckon it's a lovely home and clearly a very nice place to live, going by Michael's enthusiasm. I think we've seen that there's nothing particularly difficult, expensive or complicated about this high performance zero emissions house. But it does leave me asking, why aren't there more of them? I'll be following the performance of the zero emission house over the next 12 months as part of my research.
So that gives you a bit of a little bit of a tail look at what the house looks like. That was only done a beautiful sunny day. And this series of videos is going to, they've actually got a house up in Sydney. There's one that's now available on their website as well. So Josh's house got from the unit, and there'll be videos there of that house. So that's a really interesting house up there. Okay, that is it. I'm sure Adam can answer questions, but I'm happy to take questions about it all. Yeah?
Actually, probably a question for Adam about some of the things you alluded to in the video about builder training. Were the trades that you used on this house the same guys that were also building in the rest of Lorimer, or were they a deep green builder?
No, the usual crews.
Yep.
But certainly there was a bit more attention from us as we were building it to the fine points of making sure we got the infiltration right and not slamming huge holes in walls and things like that. So yeah, it's something that I think across the industry there's a lot of I suppose, yeah.
And I think one of the other things perhaps I should mention, right in my mind, is we did have the home open as a display home, and we used Henley put in their normal sales staff, so that normally would go to a display home. And really they probably didn't have a full appreciation of what the house, the features of the house. So, that people would come on and say, "Oh, tell me about that." But, "Oh, well, 4 bedrooms, it's got an ensuite, it's got some windows," and they really didn't have that knowledge that about the special features of the home. And Henley,
also when we sold it.
And the same when we sold it too. So it was sold through Lend Lease, and the agents there didn't really get the features and the special features of the house. So people were coming to look at it, and it was really hard for them to get that knowledge. So
as a comparison, Adam, what was the cost versus the one next door, for example? I assume you guys did the whole estate, so how was it relative? Was it sort of 10%, 20%, 5%?
I think it was around about 15%.
15% more expensive?
But we've subsequently built more energy efficient homes since with lesser increments. Yeah.
Okay. So are you talking about the sale price or the build price?
Well, sort of how it was marketed from the sale price and how it performed then when this couple bought it versus other.
They've got to be interested in
The
how that
couple
ends
that
up.
bought it in there got a fantastic deal. They sold it. Well done them.
Did you guys give them a budget then or something, or how did you manage that? Like what basically wrote up the specification of the actual home, what you did for the actual home?
Initial build.
Building the
Initial
house.
build, was it, so did you give them a specification, did you give them a budget, or how did you,
We
what's
were-
the driver?
When we built the house originally.
Well, yeah, did you specify all the...
Yeah, we did. So we worked very closely with Henley. So it was
with the intention of managing your budget?
Yeah. So the idea was, as Adam says, it was about maybe 15%. A lot of that went in things like, at the time we built it, things like timber double glazed windows were very, very expensive. So there were certain things on there, and the PV system at the time was a very, that cost a lot. So, and a lot of those costs have now come down. So the whole intent was really to keep the build cost around about the 300 for the house, about the 300k mark. So it was it was a bit of a premium. So from Henley's range, it was probably one of their premium homes that they would have. But the whole idea was to try and keep the cost relatively close to what you would go if you were building another stock standard project home, premium home.
Well, I would imagine that your brief was that you wanted to show that this had good ROI on the whole building. And
Yeah.
so therefore you would have had a budget, you would have worked out the numbers and assumed that's a sort of post-mortem on that.
Yep.
And then basically say that was, from what you opened up with, that's the demonstration you want to show
Yep.
that's actually economically...
Yeah, that's right. Yeah.
So yeah.
Yeah, that's the approach, and that's why a lot of stuff is so the house itself is just a brick. It's a brick veneer house on a insulated concrete slab. So there's nothing very special about the way the house was built. We just paid more to be up insulation levels. We paid careful attention to the ceiling of the house. So the expensive things really were things like the double glazing. We had pretty much an off-the-shelf hot water system. The PV system just.
In my experience, people have trouble understanding the ROI. You say that there's numbers and figures, they'll go,
Yeah.
they don't really know.
Yeah.
Nice house. Even the agents now say nice house.
That's right.
I actually spoke to agents to say that solar that actually doesn't actually increase the value of the house.
I sometimes play games. So sometimes when I see a house in my area, I live out in Blackburn, and so there's a few nice-ish houses out there. And when some of the more better design homes pop onto the market, I love going there and just seeing how the poor old real estate agents sell it out, and they get so much stuff confused, and they'll get orientation muddled up. Now they'll get thermal mass and insulation. They constantly get it round the wrong way. So it's interesting in that. From the real estate agent's point of view, they really don't know how to sell these homes, and then the builders, again. Not necessarily wanting to pick on volume builders, but the vast majority of people, when they go to build and buy a new house, they're going to build a new house, it's going to be through a volume builder. They're going to go to these estates and they're not going to employ an architect. It's about 5% of homes, probably less, are actually architect designed homes. We've got talking to one-to-one. Most of the time, people talk to the salesperson at the display home. It's all decided there and then. And the first time they actually ever see the builder is when the house is actually under construction and started construction on their site. All the time they spend in going into the office, it's all to the admin people and the sales people and the finance people. And you never actually speak to an actual builder until the house is actually lay the slab on the ground. And I've built my own house just recently, and I had to do lots of hand holding. With the builder there to ensure that I was getting what I was after. So I've got my home's about a 7.5 star, but it was interesting. I put in things like double glazing, and I remember getting a phone call from the builder or from the finance people saying, "Oh, great news! We're able to reduce the amount of insulation in your home because you've got the double glazing there. You only need to achieve 6 stars, so you can take out some of the insulation because you've got the double glazing." And you're missing the point.
That is actually the trouble. I'm thinking my background, constructability from building. That's what they actually focus on. When you actually specify things, they always go. I had this morning when I was in material talk. What's the easiest way of doing it? So the trade people always look at the easiest way of doing it rather than the actual.
And the salespeople most people are driven by the dollar. So what's the cheapest house I can? I want a house of X number of square meters. What's the cheapest house I can get for?
Michael, can I challenge one aspect of your presentation?
Yeah, sure.
You focus very much on temperature. The nice thing about temperature is you can actually quantify it and record it, and it's pretty straightforward. What I've discovered, though, in my place is that temperature and comfort are not the same thing. And the amount of, a pleasant breeze coming through the house on a summer evening going into night purging is delightful. Even though it's going to be a bit warmer. A draft in winter is murder, even if the temperature is actually a lot higher. So temperature and comfort are not the same thing.
No.
You've shown temperature, which I understand that you can measure that. Comfort requires people, and some of them are variable, as you've discovered. But is there any way to go to that next step and actually go from temperature, which is not comfort, to actually comfort?
Yeah, look, it's a really good question, and it's one that we have tried to, particularly how can we quantify, because a lot of it is just, it's a personal opinion, people, you're quite right, and even if you've just got ceiling fans going, the temperature might be a bit higher, but if you've got that breeze, it's going to feel more comfortable.
NATO's modelling does take comfort into account. That's what the assumptions are in the NATO software.
The comfort it takes into account is a relationship between humidity and temperature.
And
there's a standardised
and cross ventilation. And not,
so
it's not.
But it's an assumed amount.
It's an assumed thing.
But it's a really interesting. I mean, we've talked about, could we put anemometers? But the problem is to get breezes there, you've got to have the anemometers hanging in the middle of the bloody living room.
The first thing about refrigeration air conditioning is that you've got this bubble. Like, you might go from 20 degrees to 25. You can go do a survey. You've got relative humidity. You've got the psychometric charts. You've got all different things. It's such a very subjective thing.
It is. I'd love to come up with an answer for it, but it's a really tricky book, because you're absolutely right. It's very much comfort is very much a personal thing, and it's a really hard one to measure.
I'll just comment on that. I've just done some work with a friend where I got her house upgraded quite a few stars by getting Ecomaster to come in and do a full retrofit on the place. And the chap sitting next door to me put PVs on her roof and give her some control over her energy use and stuff. But what was interesting was the first thing she said was how much more pleasant it was because it was so much more still. So you think about the temperature, she said it was much more still and much quieter. She was in Albert Park, and so the noise is obviously potentially a bit of an issue. But that was, I thought, quite fascinating. She would say, look, bugger the fact that I'm now, concrete, etc., which she's quite pleased with, but she was really emphatic about those two things that stood out.
Yeah. Look, it's interesting, and one of the things that's been talked about, and I sort of mentioned a little bit in the video there, how to market these houses, and it's really more marketing on they're comfortable homes to live in, they're more livable, you're going to be enjoyable. And you listen to Michael, the new owner, and it's those personal things. It's comfortable, it's nice to live in, it feels nice and warm. I feel really good. It's a nice, happy space to be in. All those sorts of emotive parts is really, rather than saying, oh well, it's got a star rating of this, and it's got thermal mass, it's got thermal performance of this and that, and the home's going to be maintained within this temperature band, and blah blah blah. People go, oh, I don't know what you're talking about there. All I want to know is this a really nice home to live in? Yeah.
Following on the question on heating and cooling, did you have reversing ceiling fans? So
no.
Right, and well, I'll install those, and like an air breeze operates pretty well the same way.
Yeah.
That's
Look,
better comfort.
And again, I think if you were probably again, this was designed for the mass market. So again, I think you look at homes, if people that are knowledgeable in this space, they're going to probably go down the path of having things like ceiling fans, or having a much smaller heating cooling system, whether it's just like in this house, maybe just a single split in the main living space, and that probably would have been fine. So things like that, but part of the rationale behind the house was that we wanted to try and build a house that appealed to that mass house buying public. So people would go in and say, oh yeah, it's just like that. It's like the other display home I looked at next door. It's got my ducted heating system that I want. It's got everything else. It's got my ensuite. It's got my other bathroom. So that was the idea, was to try and have a home that is going to be highly marketable to the mum and dad buyers out there. So it probably wouldn't be the house that somebody that is specifically after a passive designed home would actually design necessarily.
Question probably more for Adam. How many people care about orientation when they're buying or building a house? Because it's something I'm so passionate about. I can understand why so many houses I see are going up and it's
I think people that understand obviously want it.
Those who don't know.
And it's, I think the challenge for a builder like us is to actually get our salespeople to really convey the message of why it's important and to try and help them build a comfortable house.
For me, it's not just comfort, it's actually, well, it is comfort, it's enjoying that.
It's enjoying,
sunshine.
it's like that,
Coming
it's
in,
emotive. Look, it's really interesting on that aspect of orientation, that other study that I did on looking at we took 400 homes, just random homes across Australia that have been built in the last 8 years or so, and did analysis on me. And one of the things that we looked at was orientation. We looked at how have the windows been positioned. Did we see any change in the percentage of windows on each orientation of the home? We found virtually no change. We basically found they were evenly spread on each orientation, and again, it comes from the volume home builders. They design homes that are basically going to fit on any block, on any orientation. And so what we saw, in fact, in Victoria, believe it or not, it's on the high star rated homes, we actually found a slight increase in the amount of glazing that was facing west. There you go. But virtually we saw that orientation, so the mechanisms that the builders were using to achieve the rating, orientation and glazing, they reduced the glazing area, so the amount of glazing in the home came down by about 20%. But the orientation didn't change a lot.
Just coming back to that point about comfort, one of the big factors that hasn't been talked about a lot, someone just touched on it, is humidity. I think the ideal humidity is between 40 and 60%.
Yeah, that's right. Yeah.
So if you've got a situation where you've got low humidity, you then opens up the opportunity for evaporative air conditioning, which is obviously a lot cheaper than and so on. If it runs up the other side, you've got the opportunity to dehumidify and perhaps create get the water from that somehow. Harvest the water, that kind of thing. I don't know how much work you've done around that.
Look, we haven't done very much. I mean, look, evaporative cooling works pretty effective in certain climates. It's pretty effective. I've certainly got it in my place. I think in the Melbourne climate it works well. It's not for everybody. They've got a lot better than the old swampies that they used to be. And if you know how to operate those systems correctly, they work very effectively. And when you do have high humidity, those cases we do occasionally. Again, understanding that running it with the water pumps going on an evaporative system is not going to help your situation, and perhaps just running it without the pumps on is going to be the best, and you'll just get that cooling breeze passing through the house rather than pumping more humidity into the home. So. Yeah, it doesn't work in all climates, of course. So in the tropics, evaporative cooling is not going to work. But certainly in dry climates in Melbourne, I think it's pretty effective.
And the other thing you mentioned was the opportunity for dragging air out from the atmosphere at certain opportune times. And then the other thing to consider there is dew point. So you don't want to be creating problems from that.
Yeah, look, it's an interesting. You talk to some people, some material manufacturers, and they get concerned about moisture inside cavities and stuff like that, and rotting timbers and causing mold and mildew, which comes back to indoor air quality issues potentially. So it is a bit of a careful. It's a difficult space, but yeah.
Excuse me, we'll take another 2 questions and then we can have an informal question-answer session.
So just to get back about talking about the builders, how the builders have to be educated. I know both the HIA and the Master Builders Association have green building components. And over the last 5 years, they've really lifted their game in terms of providing information to the builders who've been accredited.
I don't know, I've got to be careful. I don't know my cynic hat on here. The HIS.
I'm actually a builder, by the way.
Sorry?
I'm actually a builder, by the way.
Yeah.
I'm quite curious to hear.
Look, it's in, I mean, by and large, the HIA and the NBA have not been great fans of energy efficient homes. They've fought tooth and nail for any improvements in increasing the regulatory requirements. They have fought tooth and nail. They have constantly put out things saying that it costs, oh, you can't do that because it's going to cost $10,000 more on the cost of a home, without any evidence to support that. So, look, my cynic hat is that it's all a bit of greenwash. I shouldn't say that. I'm sure there are good builders out there, and there are builders out there that do know what they're doing and do know how to build these things. But the industry itself, I do find they are very hard to work with, and they really it's really not on their agenda. It's all about affordability, and the dollar is everything. So yeah. Sorry, I'll go to you've been very patient right back there.
Sorry, I just finished building. I didn't build it myself. I went to a builder, and both the architect and builder explained exactly what I wanted. The result has been 7.4
Yep.
rating. But not what they're doing. For instance, just recently I went up the roof, and they put an exhaust fan. They took the insulation off. That insulation, it's over there, still. Around ceiling, they put extraction with the ceiling in, took the insulating, left it off. Things like that, which immediately, whatever you try to do, it's lost.
Yeah.
So the builder might be good, but it's not the builder who's doing it.
All
the subcontractor goes to another contractor, and the contractor couldn't even start sometimes.
Yep, look, yeah, and it's the same. We get the same story with downlights. There is a requirement that you have to remove insulation from around downlights, but it's only quite a small area. But what tends to happen is the insulation installers come in and they rip it back in half, and so you've got this huge gap. And we've done so. I have to on here, but we've done thermal. These 400 homes that we looked at. We did thermal imaging of the ceilings, and you can see where the downlights are because there's big gaps around them where the insulation has been removed. So there's a whole lot of educational that's right through the entire, not just the builder. And the other interesting thing that we've seen too with that study that we did is the compliance side of things. The inspection cycles that are laughing down there. Yeah. The inspection cycles they're after the structural, so they come and check the slab, and they check the frame, and they check the and there's nothing is done on the energy efficiency aspect. That's all missed by, and I would think that there's very few building inspectors stick their head up into the ceiling to see whether the ceiling insulation's been installed, and they usually don't know whether the wall insulation's been installed because by the time their plasterboard's up, and so you've got no idea whether it's there or not. So there's a whole issue there around the compliance and the checking of the that these things have actually been done in accordance with not only the building regulations, but also in accordance with what's on the plans. So
just gets back to before I say constructability. The installer comes in, he's supposed to get in, get out, he gets paid $500, whatever, he doesn't care what the trailing piece of the house, and they'll just do whatever that, and they don't basically understand the consequences or size of that. It's just bang for buck, out, see you later.
Yep.
So,
yeah.
Does that home come with a user manual?
It did. They got the entire report that was done on the house. So.
I mean, to help the user.
Yeah. So that particular one, yes, it did. But it came with a very, very detailed user report. But yeah, I think this is one of the things that's probably needed in the industry. With nearly any other thing that you buy, you get a user manual. Whether you read it or not, I don't know. But you do actually get a user manual. Whether it's a car, whether it's a blender, whether it's anything, you use your phone. With a house, most expensive purchase you're ever going to make, you get nothing.
But you mentioned the occupiers' behaviour is important.
Well, I think as you want to get that, like I said in the video, you know, as you want to get particularly with the higher performance homes, as they get higher and higher performance, they require more and more. They won't just do it in isolation. They do need that user interaction. They just won't operate. They'll perform okay, but that full potential won't be realised, and it really comes down to the occupiers of the house need to understand how. It's as Adam said, it's a bit like a car analogy. If you drive a Prius like a Ferrari, you aren't going to get the fuel consumption that it states on the Prius manual. So it's a little bit like that with houses as well. If you don't operate them the way they're meant to be operated, you're not going to get the performance that is expected from them. So, yeah, but it's an interesting one about how do you educate the public. You know, you're a bit preaching to the converted here, so it's really the big issue is that the vast majority of the buying public, how do you teach them to the benefits of operating their homes effectively? Yeah. Sorry. Yeah.
I've got an observation, and I'm going to have to put on my second hat, I think. I really like the point you made. It doesn't work without the education. But how do we give the incentive to people to take on board that education? The only way I can think of is you put a price on doing it wrong.
Yeah. Well. Yeah.
Well, Peter, if money's not enough, then I don't know what is.
Yeah. I think that's. Look, and I think at the end of the day, I think at the end of the day, it is the dollar that drives it, and dare I say it, rising electricity prices, maybe that's a good thing.
Our biggest hope is to try and educate kids at school.
Yeah.
And understand when they grow up.
Well, look, it's great to see. It's really exciting. There's another. It's really exciting. I do some in-home, in-school sessions with like carbon kids and stuff like that. And it's really heartening. You go to particularly primary schools and you see kids. They get it. They are really switched on and they understand what you're talking about. And so, yeah, and then they go back and they tell mum and dad, so, oh, you know, we should be doing blah blah and blah. And it really does. That's encouraging. You go to those schools, and you talk to those kids, and you see how enthusiastic they are. Perhaps the next generation will get it right.
Until they become teenagers.
Yeah, well, that's right. That's right.
All right. One question on heating, or a comment, and that is a lot of older people like direct heating. You know, their legs are cold, their head don't want to get hot, and so they like to have little things that distract them. And what the sort of implications are on that?
Yeah, they can be. Look, it's I'll talk about another project that I'm working on. I'm working with energy monitoring a whole lot of low-income households at the moment, and that they're acutely aware of their energy costs. So they try and minimise their consumption of energy as much as they can. And one of the things that we've seen happening is now some of these homes have got relatively efficient gas ducted heating systems in them. And they won't use that, and instead will use little blow heaters and radiators and stuff like that. And their energy consumption is through the roof because they leave these things on all night. Because I think, oh, it's only small. It won't use anywhere near as much energy as my efficient gas ducted. Well, they don't know this is efficient gas ducted heating, but it is. So you see these huge increases in energy consumption because these little. But people just don't realise, some of these ones, they're 2,000 watts. They're big. That's a lot of power. So yeah, it's a tough one because they can be real energy traps. Little meters. Yeah.
All right, ladies and gentlemen.
I'm hanging around, so yeah.
Yeah. Let's thank Michael. Thank you very much. We'll have an informal discussion next door. We have slight light refreshments, so you can still ask any further questions. So thank you very much. Thanks all of you. And just stay tuned. Next year we have lots of more talks. Just to give you some idea, we are planning for energy storage solutions and also community energy and few other talks. So stay tuned with ATA Melbourne branch website. Thank you very much.